Hey guys, so we're with Bob here at Trainfest right now, and he's going to kind of show us the layout as well as some of the signaling that he was in charge of, right?
Yes.
Yeah. So he's going to tell us a little about it. So Bob, kind of explain the basic of the signaling on this layout.
Okay. Signaling on a layout is all done with excuse me, Arduino computers. It's a Arduino Mega 56 I/O port. It has custom software in it. The software is pretty much the same for all the control points on the layout. The control points or crossovers are where the signal logic resides. Also on the crossover modules, we have the detectors. So it's also detecting in the forward direction of travel, and that allows us to put that intelligence on the crossovers so we can put any module in between. So we can have any length of a signal block between crossovers or control points. The detectors are Bruce Chubb's DCC optimized detectors that were built from circuit boards. Signals on the layout are all BLMA signals with signal bridges from Overland Models, BLMA, NJ International, and Train Camp Models.
Cool. Okay, so like the signals like right here in front of us.
Yes.
So those are both controlled by the same Arduino or two different ones?
The Arduino for this section is with this module. So these signals are controlled off of that module. They're also taking inputs from adjacent control points, but the logic and the detectors are all reside on the modules that have the control points or crossovers.
Okay. So then each module that has some sort of signal control has an Arduino in it.
Yes.
So they're kind of separate subunits.
Right. There's 9 Arduinos on the layout.
Okay. Am I correct to say that this was your layout? Is that what I heard?
Largely, yes. We're a group that's been together for 40 years. This layout is more of a home layout now. It's a home layout that travels well.
Okay.
So
is it in your home?
Yes, it is.
Okay.
And one of the other points with this, because it's a traveling layout, the signals are made to pop out.
Okay,
so
that's cool.
They plug in. It's a 14-pin DIP that's used for integrated circuits, and that plugs into a well that has a receiver for it, and that way we protect the signals from getting damaged when it travels. Also, if somebody happens to hit them, typically they'll pop out and not get damaged.
Okay, so I saw a couple dwarf signals on the layout over on the other
Mm-hmm.
side. So are those related to switch turnout positions, or?
Nope, that's the layout is.
We go take a look at them.
Oh yeah, sure. The layout is signaled to be bidirectional.
Yeah, like the one up here.
Oops, everything just went out.
Up.
That's interesting. That's interesting. No, the dwarf, all that does is that's just signaling for if you're running opposite main, opposite direction of travel. So that's just allowing the engineer to see what's coming.
Got it.
So this is dual signaled, bidirectional signaling.
Got it. So,
and which simulates what was on the Santa Fe Railway on the Illinois division.
okay. So then the kind of like the signaling kind of detailing, is that what you kind of based it off of?
Basically, it's based off of the Santa Fe prototype.
Okay. Yeah, so can we take a look underneath at like one of these
Sure.
Arduino modules?
Okay. Under the layout, this is where the Arduino computer resides. There's a board that's attached to it, like a daughter board, and that's where all the connections connect with the inputs that are coming from all the turnout positions, from the detectors, and the outputs that you can see here for all the signals on this module. Over here, this is the detectors. That's the Bruce Chubb DCC optimized detector, and you can see the one that has the LED lit, that's detecting occupancy. So much like the prototype, when the detector detects the presence of a train, it will drive its output to ground, and that ground output goes to the signal to our Arduino computer, and then the computer determines what aspect the signal is going to display.
And then you said that, I think earlier, this was to isolate.
All that is just an on-off switch for the local track. So in case of a short, because this is all DCC on a large bus, we can just turn off sections of track, like block wiring, to isolate a trouble.
Okay, just a couple more questions here. Did you also do the, I think, turnout controls here?
Turnout controls, all that is it's got very simple logic on it. We've got a barrel key lock on here, and that allows us to lock out the turnout. So at a public show, you can push the button, nothing will happen. When you energize it with the switch key, then you can throw the turnout that it's associated with. These are located on both sides of the railroad because we operate on both sides, inside and outside. So that allows a lot of flexibility and allows us to lock the turnout, so we have no possibility of derailments.
Got it. So what's the difference between the red switch and the green switch right there?
The red switch is when it's on the main line, and the green switch is when it's off the main line on the siding. This is energized right now, so if you throw that, this turnout throws right there.
Gotcha. So then, did you do pretty much all of this by yourself, or?
There's a group of us. It's a very informal group. Like as I said, it's a home layout that travels well. So there's about 15 or so folks that we've been involved with for a number of years, and we've also got new generation of people in that. So typically at a show, we'll have maybe 6 or 7 people come out and run their trains in the layout, help set up, right, take down.
Got it. Nice. And so you had help with kind of all the Arduino software, wiring it,
one of our members is a retired programmer, so he wrote the code for that.
Got it.
I'm more of a hardware guy, so I did the hardware.
Understandable. Yeah, this is really cool. The fact that you can interlock modules is pretty cool.
It can set up in any configuration. It's flexible. The wiring harnesses between the modules are standard, so it's the same wiring harness, the same RJ45 jumper for the signals. So it's very simple to wire up. There's no thinking involved.
That's really cool. Well, thank you, Bob.
You're welcome.
Been a pleasure learning about the really cool technology going on here.
Okay.
Thank you.